Good morning, good afternoon, and good evening. My name is Jean-Louis Diascorn. I'm a product manager for encoders at Harmonic. I am also leading the company advancement of AI for video compression. I am very pleased to present you this presentation about the benefits of AI-improved video compressions for OTT during crisis. Let's look at the agenda. We will start with an introduction of the crisis we are talking about, and then the first reactions to that crisis. And I will present the AI-based compression. The real-life examples will give you exciting figures about this technology. And we'll have a short conclusion before the Q&A session. Everybody has seen a traffic surge during COVID-19. Here are some figures from a service provider in North America. They saw a 30% increase in peak traffic, 38% increase in streaming and web video consumption. They reported 25% video on demand, hitting record highs year over year. We have seen also some requirements from national agencies to do something about this traffic surge. And as you know, this is happening everywhere. Here you see an information indicating the EU Commissioner has requested to act on this bandwidth. The first reaction was to reduce resolution. As we can see here on these press clips mentioning Netflix, YouTube, Prime Video, reducing resolution. Indeed, reducing the resolution makes the bandwidth reduce as well, but it also reduces the VQ. You've all noticed that when viewing content, if the resolution is dropped, you notice it. With large 4K screens, we have been accustomed to nice HD pictures. Dropping to SD is really annoying. So, reducing resolution reduces the VQ and is a poor decision. But compression technologies have evolved. The solution is to reduce bits, not quality. Reducing the bandwidth, the bitrate, the storage are the important goal to reach. Reducing the quality is not the goal. You want to provide constant video quality, and hopefully you want also to cut bandwidth by up to 50%. The solution is the use of AI-based compression technology. Before, without AI, some improvements were not developed because they were not cost-effective. They were taking too much effort for the benefit they could provide. AI-based algorithms allow to make progress faster than before, and therefore allow to make more improvements in compression. The reason is that AI is particularly suited in helping taking decisions and detecting. AI is coming everywhere. It is not just about detecting cats. AI starts to being used for medical applications to detect tumors, for example. And of course, it is a key technology for autonomous vehicles. Detection and decision are essential advantages brought by AI. And we are using these advantages for video compression. Let's look at dynamic encoding style, harmonic IQ, as a key example of AI usage in compression. Dynamic encoding style is also called content-aware encoding. It is the application of AI technology to bandwidth saving. AI is used to take decisions in the compression algorithm. IQ leverages the human visual system to focus bits where they matter most for the viewer. For example, faces are well preserved. On the other hand, large crowds which contain lots of details and are costly to encode can use in fact less bits if it is done carefully. Here is the concept used to implement AI for video compression. It is a two-step approach. The first step is a learning phase. Many test files feed an AI offline learning system which produces a prediction model. This prediction model is then downloaded into the live system. The second step is the actual compression done by the live system. It will use the prediction model to improve the performance. Let's look at how this two-step approach applies to dynamic encoding style application. Here the test files include video content, but also encoding styles, which are different configurations of the encoding core. And they all feed the AI system. After many hours, thousands of content, video content, AI will produce an encoding style prediction model. And as said before, this prediction model will be downloaded into the live system. This appears just like a video software upgrade. And during the live encoding, it will be used to tune the encoding core. In addition to bandwidth saving, the benefits also include improved end-user quality of experience. Thanks to lower bitrate, there is up to 3 times less rebuffering, and 1 to 3 seconds quicker startup time because less bits are needed for startup. There is also up to 3 times less profile switching. In fact, the video will stay at a higher resolution longer because the bitrate is lower with content-aware encoding. And finally, this is less bitrate competition at home. Because of lockdowns happening everywhere, people stay at home and use their Wi-Fi or internet more. Reducing the video bitrate improves the experience of everyone in the home. Deployment of IQ is easy. It is a software feature. It has no impact on the latency and no impact on the density. It is also transparent to customer applications such as dynamic ad insertion. And now some real-life examples during crisis. First, a telco use case reacting to COVID-19. This is a streaming service with more than 10 million subscribers on fixed and mobile, more than 50 channels, many applications, live of course, VOD, cloud DVR, time shift, and server-side dynamic ad insertion. It's a challenge because of bandwidth pressure during COVID-19. They needed a solution to be deployed fast without changing current infrastructure. Here you see the graph provided by the customers, where you see a big drop when IQ is activated. In fact, the backbone traffic reduction was 50% and the CDN peak usage reduction 30%. A second example is the OTT provider use case during tests during COVID-19. This is a European OTT provider. For studio content, you see several profiles of OTT, and the same for sport content. Comparing IQ with normal compression, you see large savings, especially at a higher bitrate. In fact, studio content bitrate reduction was 40% and sport content bitrate reduction 30%. These are great numbers showing the great advantage of AI-based compression to save bandwidth. The takeaways for this presentation is that reducing resolution reduces VQ and is a poor decision. Compression technologies have evolved. Deploying AI-based compression helps to drop the traffic surge. We have seen one application of AI in compression that allows bandwidth saving. There are more applications. One is dynamic resolution encoding. In this application, the AI algorithm will select the most appropriate resolution for the content. Usually low resolution for fast movement and high resolution for slow movement. It reduces the CPU cost and provides a better quality of experience. Another one is dynamic frame rate encoding. In this application, the AI algorithm will select the most appropriate frame rate for the content, usually high frame rate for fast movement and low frame rate for slow movement. Again, it mainly reduces the CPU cost and provides a better quality of experience. There are many other uses of AI in video creation and delivery possible. This is just the beginning. I thank you very much for your attention and now open to any question you would have.